Hello everyone and welcome to our engineer interview with David. Now, my name is Scott and I'm your host for today. Before we start, I'd just like to say thank you very much for signing up to this year's competition. For those of you who don't know, this is the Leaders Award competition, where we ask the question, if you were an engineer, what would you do? Pupils from the ages of 3 to 19 anywhere in the UK can take part, and every single person receives a named and graded certificate from a real-life engineer, just like the ones we interview. Now, during these interviews, we're going to speak with engineers who work on loads of different projects, all of them showing the wonderful, interesting and exciting things that happen when you work in engineering. Our special guest is going to start with a 10-minute presentation all about how robots are helping create a better and safer world, and then we're going to follow that up with some questions. But for now, that's everything from me. I'm going to pass over to David, who's going to start his presentation.
Yeah, thank you very much, Scott. So I am going to start sharing my screen. Excellent. Well, thank you very much. Thank you very much, Scott, and thank you very much, everybody, to be here. It's a pleasure for me trying to share a little bit and try to inspire people about engineering in general, but also about the work that we are doing in robotics and particularly in robotics for nuclear. So my name is David Marquez-Gamez, and let me start introducing the toys that I am using. So let me start after this entering with a robot, introducing myself. I want to share with you a little bit about myself, who I am, what is the work that I am doing. So first, I am David. I work in AtkinsRéalis as a mobile robotics and IoT lead. So I am part of a team of engineers working in digital and robotics for nuclear. So where I am from, this is important to mention because I guess that you have noticed I have an accent. So I grew up in Venezuela and Colombia. So my mother tongue is Spanish. I speak Spanish. I spent all my child years, school years between Venezuela and Colombia. And this is where my initial school years base come from. So after that, I decided to go to the university in France. So I moved from Latin America to Europe, and I went to the University of Toulouse, where I decided to have a PhD. So I have a PhD in robotics and intelligent systems. So I spent then several years, so I can also speak French fluently. And after that, I decided to start working in industry deploying robots. So part of my initial professional years was working deploying or using robots for manufacturing, the manufacturing industry, and I have the opportunity to work with Airbus, for example, that is an airplane constructor, Renault, for example, that is a car constructor, etc. So deploying robot for manufacturing. After several years working in France, I decided to take a next step and a new challenge, and I decided to move to the UK. Initially, I was part of the University of Liverpool, so I moved from France to Liverpool to work in the university, and I working like a research engineer. Of course, always working in robotics, but doing engineering applying to research. After Liverpool, I have the opportunity to join the University of Oxford. That was a very nice challenge in the next step in my career. So I joined the University of Oxford like a robotic engineer too, leading a team of software engineers working in robotics. So I was part of the Oxford Robotics Institute, that is part of the University of Oxford, and I have the opportunity to work in many interesting projects, working with very clever people around the world. And this is one of the examples of working in quadrupeds. For example, that this is legged robot that you can see here, kind of robot dogs. So after my adventure in Oxford, so I decided to move back to Liverpool, and now I am working in AtkinsRéalis, like I said at the beginning, like mobile robotics and IoT lead. So I am an engineer. So, but the question here is what an engineer do, or what I am doing. So I am basically solving problems. So my day-to-day work is about solving problems. So I like to try to figure out solution to difficult problems. And my work is about new ideas, proposing new ideas. Teamwork is very important. It is part of my day-to-day work. So as part of my work, I work with teams that are around the world. I work with people that is in Canada, in the US, in France. So teamwork is very important, and is part of the skills that you need like an engineer. Part of my work is also keep learning. So keep learning every day. You need to keep, or I try to keep reading. I try to keep updating my skills and try to be on the top of the technology. So this is about continuous interaction, and try to understand what is happening in everyday technology. So, but why this is important? Finally, because we need, or the work of an engineer is try to improve the quality of life of everybody, in fact. So I am an engineer working in robotics for nuclear. So this is a good introduction. It's just to showcase and to demonstrate what the nuclear side. So it's about generating clean energy for the next generation. For you join all the joint minds that are here listening. It's about generating clean energy and generating a better planet, in fact, for all. So my work specifically is in nuclear, but what means robotic for nuclear? So the robot that we are deploying is to try to do work that are dirty and dangerous. So we want to protect operators and protect people, and try to put robots to do this difficult work. basically, like I said, this is about putting robots to do difficult tasks. So let me give you an example. So dirty, dull, and dangerous task. So let's say that we want to clean something, and clean up is something that normally operators do manually. So is to take waste items between 2 and 8 kilograms, for example. And the idea is that we want to take this task that people is doing manually and try to perform this with a robot. So the operator or the person that was doing the task manually become a robot operator, and in this case we can use the robot to perform this task. So in this video you have a real example of a task that we implement where we put in the robot to do this clean up task. So the robot was able to take these bags that you can see here and transport the bag from one side to another. And in this case, like I said at the beginning, the operator that was doing this task manually become robot operator to perform this task. So finally, I want to finish my presentation about keep thinking, keep dreaming about next step, keep dreaming about technology. This is about making the world a better place for everybody. So maybe one day, and I hope that one day, one of you or all of you will be the next engineer that will be deploying robots for the next generation. So thank you very much, and I am happy to answer any question.
David, thank you so much for that. We do have a few questions coming in. For anybody who does want to ask a question, make sure you type it in the chat and we'll try and read it out. David, if I can just ask you to stop sharing your screen, we've got a few questions we can start with. And the first question comes from Jack, and Jack asks, why do some of the robots have a mesh around them?
So can you repeat the question?
So it almost looked like some of the robots had cages or something around them, and we were just wondering why that is.
So yeah, that will depend of the task that we are doing. So in this case, in this example, so the cage is because we are doing the operation inside this particular setup. This is not a limitation, it's just the use case, or it's just the task that need the robot to go inside these boxes, let's say, cage boxes. It's just the setup of the place, let's say. But there are not other reasons that depend of the task.
Okay, we've got some more questions about what the robots are made of. This one comes from, this question is literally, what are the robots made of?
This is an interesting question. So robot can be made from different material. Can be plastic, for example, can be aluminum. So that will depend. So an industrial robot is normally need to be made of a material that need to be resistant enough, a material that need to be made for dangerous places. So in this case can be metal, aluminum, for example. But today there are many robots that are made from plastic. So 3D printing material, for example. So there are not a rule. And that will depend, in fact, of the utility that you are gonna do to the robot.
Okay, so and more on how robots are built. Miss Campbell asks, which tools are used to make a robot? Do other robots make robots?
This is interesting because, for example, today, electrical car, for example, today robots made machines. Today robots made electrical component. So can we call this a robot? Maybe that depends. So robots can, and today are making many stuff. They are making cars, they are making airplanes, they are making small components. But basically, the tools that you need to do a robot, that will also depend. That start from pencil, because you need to draw initially the robot, a computer, because you need to design the robot and you need to program the robot. Like I said, 3D printing materials, soldering cables, etc., etc. So there are many different things, but basically electronics, cables, and all the hardware part is, for example, the same materials and the same tool that you will use to do a TV, for example.
Wow. So yeah, there's lots and lots involved in making
Yeah.
robots. Yeah. We've got a few questions now about you, David. The first one is, why did you decide to become an engineer?
Wow, this is a very interesting question. So, um, and to be very honest, during my school years, I wanted to be a doctor. I wanted to go
Wow.
to the medical schools. I was very attracted for chemistry, biology, the brain. So during many years, when I was a kid, during my high school years, I wanted to go to the medical school. I wanted to be a doctor, a GP. Um, I have the opportunity to do an internship in engineering place, and in this internship was the first opportunity that I had to work with electronics and robots. And this internship basically changed my life, because I was at this point very attracted about computer science, about programming, about how we can design intelligent machines and how we can
Wow.
create artificial intelligence, for example. So yeah, this is why. So I changed from my initial point to wanting to be a doctor to wanting to be an engineer working in robotics.
So you mentioned artificial intelligence, and we actually had a question from St Ives Juniors in Cornwall, which is, do you make AI robots as well?
Yes, yes, we do, because part of the work that we are doing is that we need to give the robot a brain, basically. So we need to program the robot to do the different tasks. And part of this is give the robot some artificial intelligence to take decision. So basically, you want your robot to have some kind of intelligence to take decision in function of your task. So the concept of artificial intelligence is also very big. So, but we are creating intelligent machines. So basically, that we are doing is that we are creating, or we are programming the brain of the robot to execute some task.
So that all sounds like a big task and a big thing to do. And we've had a few questions about how difficult your job might be. But this question comes from one of the students who asks, what's the most challenging part of your job?
Well, yeah, the most challenging part of my job is uh, the team working part. Is, you know, I want just to clarify that the challenge during your engineering career will change in point of where you are. When you start working like as an engineer, you have maybe technical challenge that you need to go over, and in function when you start moving in your professional life and your job, the challenge will evolve. So when I started working as an engineer in my first year, just after the university, the main challenge was technical. So was how can I take the robot to pick an object, for example. This is a technical task. So how can I program the robot? How can I go and change the parameters of the robot to do the task? Now, today, the challenge that I am facing day to day is more about interacting with people, coordinating projects, coordinating work, and so on. So that will change in function of your career.
Yeah, so new challenges almost every day then, by the sounds of things, because you work on so
Yeah,
much.
yeah, yeah,
Um,
yeah.
we've got a question from year two at St. Patrick's. Can a robot be programmed to do pretty much anything?
Uh, I will say yes, but this is a yes, very frame. So almost anything. So we can program robots to do uh, any task that we can control. So, but that is I mean, it's very generic from my side to say that. So, the challenge here is that if we have the correct inputs, the robot can be programmed to have a particular output that we want. So, in that case, I will say yes, we can program the robot to do almost any task.
That's quite exciting, actually. So we've got some more questions about you as well, David. And this question actually comes from Mr. Kier, who asks, what's your favorite part of the job?
Um, the most exciting part of the job is when you see something that starts from a paper, an idea, and become reality. Is very exciting. So, just to be able to start from scratch with a pencil and a paper and go over all the process to make this stuff become a reality. This is very exciting.
So actually seeing this is an idea and then seeing this is actually in real life how it works. So
How
you
it
see the
works
whole process.
exactly. Go over all the process, but that includes, like I said, many different challenges, technical challenge, but also challenge of coordination, team working, and so on. So it's a big path from an initial idea to see something making a reality, but it's an exciting part, and this is
Yeah.
that I most enjoyed about my work.
That's pretty special. So we've got a question in here from year two at St. Patrick's again, who said that they've been learning about materials in science. So what materials can be used to make a robot? You mentioned plastic and aluminium, but is there much more that goes into the making of a robot?
Uh, yeah, that like I said that basically you can make a robot of any material that you want. You can use robot. You can put a robot from gold if you want, titanium. So, but like I said, that will depend of the task that you need to do. If you are planning to send a robot to the moon, to the space, Mars, for example, the constraint of the space need to be taken in consideration to
Hmm.
design the robot, and the material need to be adapted. If you want to do a robot for your personal home, for example, you can make it from plastic. So there are not a rule, and there are not only one material. There are a range of material that can be using to do a machine, and in this case, to do a robot.
Wow, so a whole range of materials, but all of them have a different purpose. That's pretty
Yeah,
cool.
that can be for very rigid materials to soft materials. That, like I say, that depend of the task and the constraints, about the constraint that you take in consideration when you are planning where the robot will perform the task.
So we've got about 5 minutes left. So if anybody out there is still sitting on some questions, please get them in. This question comes from the Bank View STEM Club, and they ask, how do you make robots talk?
Okay, this is an interesting question because we can talk, we can give the robot different sensing, not only talk. Robot can listen, robot can interact. So how we can make a robot talk? So in that case, We can put on a speaker, for example, and we can translate input from the keyboard, for example, to generate sounds. So in that case, what is the process? So the process is to program, to generate an algorithm, to generate a program that will take input from the keyboard, for example, and translate that to sound using a speaker. So, and in the same case, that can be an interaction because the robot can process the information and can answer using a speaker.
So, wow. So I never would have thought of that. Of course, it needs to actually make noise. So you need a speaker in there at some point. Yeah.
Yeah. But and also if you want the robot to listen to you, in that case, you use a microphone. This is that I am doing at the moment. I am using a microphone and I am talking and the computer is processing the information and you are listening. So for the robot will be the same.
So we've got another question about becoming an engineer. So we've got a question that says, "Is being an engineer worth it? I am currently considering that career path."
It's very exciting. Like I say, being an engineer is an exciting opportunity to make a change. You don't need to become a robotic engineer if you want. You can consider become any kind of engineer, and this is basically, like I say, is putting your ideas to make a difference.
Yeah, so it's definitely worth it, I think, for whoever asked that question. So we've got time for a couple more. I like this one from Charlotte in year 5, and Charlotte asks, "Have you ever had to stop partway through making a robot and start again?"
Yes, yes, yes. Fail is a part of the day-to-day work. So failing, uh, testing robots or testing some stuff or ideas and failing and start from scratch again is part of the job. So it's a repetitive process because you need to test, you need to understand, and you need to learn from your mistakes. So yes, yes, this is part of everyday job and everyday project. So failing, starting again, and trying to move forward.
Yes, I think we hear that from engineers a lot, that failing and getting things wrong is important. It's not always a bad thing, and I think
Yeah,
doing it earlier, the better as well.
yeah. Learning from mistakes is part of an engineer. So you learn from your mistake and you change and you become a better engineer.
So I think we've got time for 2 more questions, and they're both about becoming an engineer, so I'll let them. So the first one is, what are the steps you should take now if you want to become an engineer? Is there certain subjects you should do? Is it university? You mentioned doing an internship. Are these the things you should look out for?
Yes. So an important part to being an engineer is to be involved in the STEAM, like science, mathematics, computer science. Depending of the engineering path you want to follow, you will need to learn more different things. If you want to become a robotic engineer, it's very important to learning computer science or programming, for example, mathematics. But something that I just want to share is that there are many skills related with science and school that you learn from mathematics, but it's very important also in the life of an engineer that something that we call soft skills, team working, communication. How do you talk with people? How do you communicate and work with other people? This is very, very important. I have the feeling that this is something that many school paths don't teach enough about this soft skill, emotional intelligence. How do you deal with other people? So this is very, very important in the life of an engineer. It's not only about the mathematics; it's also about team working and working with people.
Yeah, and I think that's the thing not isn't as obvious as well, because you think, oh, I need to learn this, but you also need to work with others. So I think we've got one last question that's come up that I really like, and I think we'll end on it. And it comes from Freddie. And Freddie asks, "What is your best tip for an aspiring engineer?"
Uh, my next step or my particular step.
Just like what have you got any advice for anybody who wants to become an engineer?
Yeah, so be curious, be curious. Sorry. Be curious and question everything. Sorry. So be curious, question everything. Uh, Test your ideas, read a lot, and just keep asking. This is important.
So be curious. I think that's some excellent advice. And I think that's the advice that we'll end the session on, looking at the time. So first of all, thank you to everybody out there for joining us, but a massive thank you to David for helping inspire all the engineers in the making out there, because now it is your turn to come up with your own engineering ideas. Remember and send them in to us once you've finished so that we can get our certificates sent out to you. And then hopefully we'll see you all at our public exhibitions at the end of the school year. And remember, everyone out there, if you were an engineer, what would you do? Thank you very much, everyone.